Hey guys, welcome to our senior secondary chemistry. In this video, we're going to continue with the topic nature of matter. This is the second and last video on this topic. So we're going to start with a concept map. In the first video, we did not look at the concept map, but in this video, we're going to do so. The reason is the concepts that we're going to learn in here are based or depend on the concepts we learned in the previous video. So the job of the concept map is to help us see how the concepts from the previous video and in this video are related. So in the first video, we looked at what is chemistry, and we learned that chemistry is the branch of science that studies the chemical composition of matter. Before we could look into what the chemical composition of matter is or what chemicals makes up matter, we took a look at matter itself. We did that by looking at the states of matter. Then we also looked at the change of states of matter. Then we ended this video with an introduction to a theory called kinetic theory. So this theory was trying to explain the nature of the chemicals that makes up matter. We also learned about the two observations in nature that supports the kinetic theory. Those two observations were Brownian motion and diffusion. In this video, we're going to learn more about the kinetic theory, and then we'll try to understand the states of matter and the change of states of matter using the kinetic theory. Let's get started. So here are the learning outcomes. So at the end of this video, I expect you to be able to understand the postulates of the kinetic theory. You should also be able to describe the three states of matter using the kinetic theory. You should also be able to describe the change of state of matter using kinetic theory. So we're going to start with postulates of the kinetic theory. In the first video, we learned that the kinetic theory states that matter is made of small separate particles or discrete particles. We also learned about observations in nature that support the kinetic theory. From that, the kinetic theory makes some suggestions about the nature of matter. The word postulates is more like suggestions. So postulates of the kinetic theory are more like suggestions that the kinetic theory makes about the nature of matter. The first postulate is the particles are in constant motion. This was drawn from Brownian motion, where we observed that the particles were ever in constant motion. The second suggestion is the movement of particles increases as the temperature increases and vice versa. This suggestion is drawn from diffusion. We observed that the higher the temperature, the higher the rate of diffusion and vice versa. The third postulate is particles of different substances have different sizes and masses. Larger particles have larger masses and smaller particles have smaller masses. So what this postulate is trying to emphasize on is particles that makes up water are different from the particles that makes up, let's say, charcoal. So the higher the particles that makes up a given substance, the higher the mass, and the lower the particles that makes up the lower the size of the particles that makes up a given substance, the lower the mass. The fourth postulate is going to be discussed using these two particles. So let's assume I've got these two particles in nature. So particles have got forces in between them. So when they're in contact, they can either attract each other or pull each other closer, or they can repel each other or push each other away. So we can say the particles exert strong forces on each other when they are in contact. So they can either attract or repel. The forces are in two types, attractive and repulsive. Attractive forces hold the particles together, and repulsive forces causes the particles to move apart. So repulsive forces causes the particles to move apart, while attractive causes the particles to come together. So this is the fourth postulate. The final postulate states the strength of the forces of the particles determine the physical state of matter. So these forces, which in our diagram here is in blue, its strength will determine the state of matter. It will determine whether it's solid, liquid, or gas. If the forces are strong, then it's solid. If they are weak, then it's liquid. If they are weaker, then it's gaseous state. So these are the 5 postulates of the kinetic theory. With these postulates, we're going to understand the 3 states of matter, and we're going to understand what happens when matter changes from one state to the other. So we're going to start with solids. We're going to understand the chemical composition of solids using the kinetic theory. So in solids, the particles are closely packed. Given a solid substance like this, the particles are packed like this. So we can see that the particles are so close, there's no much space in between them. So because of this kind of packing, what can we learn about the behavior of these particles? So let's assume that we have got these 2 particles here, which are close. One of the postulates of the kinetic theory states that these particles exert forces on each other, which might be repulsive or attractive. Let's assume that the forces are repulsive, meaning that these 2 particles are pushing each other away, like so. So, like the way they are moving, this will keep on moving and this will keep on moving. And if this was the case, then a solid couldn't have a fixed shape or fixed volume because of these 2 particles which keep on moving. But why is it that solids we don't see particles in solids moving away, or a solid breaking apart or losing shape? Why is it that we have fixed shape and fixed volume in solids? Let's assume there's another particle here which is also close to these 2 particles. Let's assume that the force of attraction between this particle and this particle is attractive in nature, which means this other particle is put close to this particle here. So the behavior of this particle is it will be trying to get close to this one while it's being pushed away by this one. So it will be moving left, right, left, right. When it's about to get away, it's pulled. And when it's about to get close to this one, it's pushed. So it will act as vibrating. That's how the particles in solids behave. The forces of attraction and repulsion are counterbalancing each other, making the particle to appear as if it's vibrating. So we can state that the attractive and repulsive forces counterbalance, making them vibrate about their fixed positions. Because of this, solids have fixed shape and volume. So the first thing to explain is particles are closely packed. Because they are closely packed, the forces between them counterbalance, making them vibrate about their fixed shape. Therefore, they have a fixed shape and volume because they don't get away from their fixed locations. So we're going to take a look at liquids. What are the chemical composition of liquids using the kinetic theory? So in liquids, the particles are slightly apart than in solids. Given a liquid substance, the particles are packed like this. There are spaces in between the particles. So what can we learn about the behavior of the particles because of these spaces in between them? So we can learn that the attractive and repulsive forces are too weak to hold the particles close. So the particles move short distances. What this means is if we have got 2 particles like this, the forces in between them are too weak. So the particles can move, but not that much. If we introduce another force to counterbalance the effect of the repulsive forces, this particle here, let's make the same assumption as we did in the first, where type of force between these two is attractive. So this will be attracted to this, but because the force is weak, so it will move a bit, not that much. So it will be moving like this, like this. So the particles move short distances. That is the reason why liquids have unfixed shape, because the particles are free to move a bit. So we can conclude that this gives them unfixed shape but fixed volume. So why fixed volume? Because the particles are still close to each other, but they are moving short distances. That's why the shape gets distorted. The shape can change. And finally, gases. So in gases, the particles are much further apart than in solids or liquids. Given a gaseous substance like this, the particles are packed like this. So we can see that the distance between the particles are much further as compared to solids and liquids. What can we learn about the behavior of particles in gases? The attractive and repulsive forces are very weak, making the particles move at very high speed in their available space. So given two particles in gases, let's assume again that the types of forces in between them is repulsive. So these two particles will push each other like this, and they'll keep on moving so long as there is space wherever they're heading. Even if there is another particle which is trying to pull to attract a neighboring particle, it won't be able to do so because the forces are weak. Because of this fact, the fact that they can, once they are pushed, as long as there is space, they'll keep on going and they won't go back to vibrate like in solids, or to just to move short distances like in liquids. They have unfixed shape and unfixed volume. Now that we understand the states of matter using the kinetic theory, can we explain the changes of state using kinetic theory? So we'll start with melting. So when a solid is heated, the particles gain kinetic energy. We explain this in diffusion, that increasing temperature means the particles will have an increased kinetic or moving energy. So let me read this again. When a solid is heated, the particles gain kinetic energy, and this results in the particles vibrating faster and faster, because kinetic energy means the particles are moving faster. So what happens when the particles are moving faster? So let's say this is a solid substance. We've got these particles which are close to each other. So when it's heated, the particles will start moving about. At the end of the day, the particles will be far away from each other. So this substance won't be a solid substance anymore because the spaces between the particles have increased. So we can say the particles, they end up breaking free from their fixed position. The distance between them increases, and that is what we observe as melting. So because the distance between the particles will be like that of liquids. That's why the solid substance will be seen changing into a liquid substance, because of the spaces that have increased in between the particles. So we have learned how melting occurs using the kinetic theory. So we learned that when a solid substance is heated, the particles gain kinetic energy, which means increased movement, and therefore they break free from their fixed positions. Once that is done, the spaces between the particles increase. They become like those particles in liquids. That's why the substance will now appear as a liquid. Solidification is just the opposite of melting. So in solidification, the particles between the particles in the liquid substance that is about to solidify have got bigger spaces, or they have got bigger distances between them. So when the substance is cooled, the kinetic energy reduces, therefore the movement reduces. Because of the reduced movement, the particles will start vibrating on their fixed position, making the substance appear as a solid. So we can say when liquid is cooled, the kinetic energy of the particles decreases, and this results in the particles vibrating slower and the distance between them reduces. The forces between them become strong, and they can only vibrate at their fixed position. This is what we observe as freezing or solidification. So we conclude with evaporation and boiling. Evaporation is the change of state, but boiling is not. Boiling is just something that happens when a liquid is about to boil, but is about to evaporate. But I've included it in here so that you understand why bubbles form when a liquid substance is evaporating. So when a liquid is heated, the particles have an increased kinetic energy. They vibrate faster and faster. Given a liquid substance like this, and these are the particles, so if the kinetic energy is increased, or when it's been heated, the particles will be vibrating fast and fast. A temperature is reached at which those particles at the surface of the liquid escape the liquid. Why or how do they escape? Because of the increased temperature, the increased kinetic energy, the increased movement, these particles will jump out of the liquid. And since when they're out of the liquid, there are no other particles to pull them back to the liquid, so they will become part of the gaseous state. That's how evaporation occurs. In conclusion, we can say the attractive and repulsive forces become even weak, such that particles on the surface escape the liquid into the gaseous state. So how does boiling occur, or how do those bubbles form when something is boiling? A temperature is reached at which main particles try to escape at the same time, ending up forming air within a liquid, which is observed as bubbles. To conclude this topic, there are about two most important points that I want you to take note of. So the first is liquids with strong forces have high boiling points. Why is this so? So if the forces between the particles in the liquid are strong, for those particles to break or for a particle to escape the liquid, it needs to move faster, which means high kinetic energy, which means high temperature. Therefore, liquids with strong forces have high boiling points. The same can be applied in solids, and we can say solids with strong forces have high melting points. This marks the end of this part of the video and the end of this topic, which is nature of matter. Make sure you like, subscribe, and share. If there is any clarification or any question, you can use the comment section. Otherwise, happy solving.